Let's have this one real-life example where we are going to use some important concepts in combination, which will allow us to answer such questions. Say for example, I have here, this is actually point A, and you have here point B. And we will be asked about the shortest possible route in this rectangular grid where these lines here are streets. Okay, these are streets, the shortest possible routes from A to B. So in looking into this perspective, definitely we have a lot of possible methods. Even we also have a lot of methods where it can have different lengths. Okay, say for example, one of the method that you could one of the lengths rather, one of the routes that you could take from A to B is, of course, you could have it here, there, move up. You can also move down here, and you could attack it different ways, right? That's one route from A to B. But this is not necessarily one of those shortest route. That is because you can see here that you are actually doing some what they call this one, reverse movements going towards B. So this is one of the real life examples where we're going to use the concepts of combination. Now, we talk about the shortest route. That would mean one of the examples for the shortest route is simply taking direct movements horizontally and vertically. Let's say you're moving here, okay, and then you're moving up. That is actually one of the shortest route. Yes, it may look like the route may be very long, but that is actually one of the shortest route that one can take. Another is, of course, say for example, if you're going to pass through this street, moving here, move up, move there, move up here and there, that is also one of the shortest route. Do we have the same possible lengths as we move from the white and the red ones? The answer is actually yes, because the number of ups you did for the red one comprises with this 1, 2, 3, 4, 5. Whereon for your white route, you have 1, 2, 3, 4, 5 as well. So basically, even if the routes look different, we have the same upward movement. Similarly, if you're going to look at the horizontal movement, this movement here, 1, 2, 3, 4, 5, 6, 7, 8, and 9, this still corresponds to the movements in your white route. Now, they just look differently because for the red one, you're taking a lot of corners. And in the white one, you're just having one left turn from this direction towards that. Now, disregarding the possibility of the traffic flow, definitely you have the same amount of distance, not the displacement, same amount of distance, even the displacement, yes, taken from A to point B. So how many of this shortest route, because if you have another color, let's say blue, I don't know if this could be this is observable. Let's say if we'll have here blue, this point, and that point here, and then straight into that, we'll have the same amount of ups and horizontal and upward movements. So actually, the shortest possible route in a rectangular grid is given by a certain combination. And let's derive it into this manner. Say for example, the number of vertical streets, let's say capital M, this corresponds to the number of vertical streets. Okay? And then for your, let's say, capital N, again, we are just deriving here number of horizontal streets. Okay? So for your M, the number of vertical streets, we are going to count this one here. Again, not this grids, because that is not a street. There's actually a block in that specific area. So we start here from this one street to, let me erase this. Okay? 3, 4, 5, 6, 7, 8, 9, 10. So in this case, you have here 10 number of vertical streets. For horizontal streets, you have here 1, 2, 3, 4, 5, 6. You have here 6 horizontal streets. However, these two values will not be immediately used here, because if we're talking about movement of a certain object from A to B, definitely the first movement, say for example this one here, the first movement towards the right, even this one. Let's talk about horizontal first. Towards the right here, that's actually the first step, the first move. Okay, so if we're talking about the entire horizontal movement here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not 10, but it's actually 9. So if we're talking about m number of vertical streets, the number of horizontal movement, we're talking about horizontal movements now. Don't be confused about the vertical streets and the horizontal movements. Okay, so horizontal movements is actually considered as, if we talk, that's actually m minus 1, right? We have the m minus 1 horizontal movements, because as we start from here, we don't count it as 1, but it's actually 1 movement. As for the vertical movements, similar concept here. If you're going to start with this portion, you're not counting the origin as first, but you're counting this 1, 2, 3, 4, 5. So that's actually the vertical movements. Okay? The vertical movements is actually n minus 1. Okay? So the vertical movements is n minus 1. The horizontal movements is actually m minus 1. Now, this will be better to be used than this, because for a general type of grid, we don't have a specific value. Let's say, unlike this one, we know that there is 10 vertical streets, there are 6 horizontal streets. So we have a specific example here, but for general aspect, we will be using this concept here. Now let's denote, okay, horizontal movements as another entity, or let's say another value. Let's just simply say here, I'm going to write it in general form. Okay, let's say for example, let's try to, I'm going to revise this, so I will be using m and m later. Okay, so let us just simply say according to the axis. So say for example, the vertical streets are your x's, so your horizontal movements is x minus 1. If your horizontal streets are your y's, so your vertical movements are actually your y minus 1. Now let's generalize this one here for the horizontal movement. Okay, the horizontal movement here, horizontal movement is x, what do you call this one, x minus 1. X stands for the vertical streets. To make it addition, let's say we will be using here m plus 1, which corresponds to the vertical streets. Okay, so in vertical m plus 1 vertical streets, that would be m is your horizontal movements. Okay, so if m is your vertical streets, this is your minus 1, you will have m horizontal movement. As for n plus 1 horizontal streets, you will have here actually n vertical movement. Okay, so for m plus 1 vertical streets, you can get your horizontal movement as m, and you will have your n plus 1 horizontal streets, you will get here n as the number of vertical movements. Why are these very important? Because if you're going to look into the vertical streets, and let's say assign let's say 1 for horizontal movement and assign 0 for vertical movement, your route, each route from A to B will be a combination of 1 and 0. Because if we assign 1 for horizontal movement, let's say this one here, okay, this is 1, 1, 1, 1, 1, 1, 1, 1, 1, not adding them, we will know the number of horizontal movements you are taking by a number of ones. Okay, number of ones. And for your vertical movement, if you're going to assign this 0, 0, 0, 0, 0, you would know the number of vertical movements you will take by the number of zeros. So that means all the routes are a combination of ones and zeros. Okay, even if you're going to look at this red here, say let's try to look at the white earlier, the white movement. So for the white route, don't worry, I'm using blue here, but for the white route, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 movements, 9 horizontal movements. So probably you will have here a combination of 1, 1, 1, 1, 5, 6, 7, 8, 9. Okay, that's 9 horizontal movement. And then as you move up, you have 1, 2, 3, 4, 5. 5 vertical movements. So you will have 1, 2, 3, 4, 5. This is the route taken by the white route earlier when we have the representation for each movement. As for the red route, sorry, I am establishing here the idea of the formula. For the red route, you have here movement up. So the movement for up is a vertical movement is 0. You will have here 1, 2, 3, 4 horizontal. So 1, 2, 3, 4. Then 2 vertical routes, 0, 0. Then another horizontal 2. That's 1, 1. And then you have here vertical 0. You will have here another horizontal, another vertical. So horizontal, vertical, and another 2 horizontal. You have 1, 1. Okay? So this is the red route. But as you can see, it's just a combination of 1 and zeros. And if you're going to compare both of them, they have the same number of 1s and same of zeros. Because if you're going to look at the blue route, so you have here 9 1s, and then you have here 5 zeros. And then for the red route, you also have 1, 2, 3, 4, 5, 6, 7, 8, 9. Still 9 1s and 5 zeros. So basically, each of your route, even if you're going to come up with another route here, it will be a combination of 9 1s and 5 zeros. In general aspect, the 9 here indicates the M movements and N movements. So you will have actually here, say for example, a combination of M movements and N movements. In this case, for this example, we have 5 horizontal, sorry, that's the other way around, 9 horizontal and 5 vertical. In the red route, same as, let's use this blue for the white. So 9 and 5. For the red route, still 9 1s, meaning 9 horizontal movements and 5. Okay? As you can see, when you compare them, all of them are combinations. At this time, we will be using the multi-set formula for the combination multi-set. Okay? So how do we look into the formula here? Now, this is not the formula that we will be using. The actual length that each route will take will be M horizontal movement plus N vertical movements. Regardless of which route you will take, as long as it's one of the shortest route, you will have this as the total. Okay? Total route. And take note that these routes are combinations of 1s and zeros, in this case for this illustration. And this white route is different from the red route, right? That would mean this is not a combination multi-set, but it's a permutation multi-set, where we know that there are M plus 1 for our total. The number of path to the horizontal and vertical is provided by M plus 1, and the number of I's and zeros are indicated by M and N. Let me use another page here for the illustration of the formula. I'm just going to illustrate the formula, so pardon for making this very long, so that we will be able to understand and be able to apply this in our separate situation. Let me add another page here. That would mean that if M plus 1 would the number of overall movements, and then your M is for your number of, earlier it was actually horizontal movement, and N stands for the number of your vertical movement. If we're going to look into this using the permutation multi-set formula, it's actually identified by M, the total. Okay, you will have K factorial. I'm not going to use N because I have here what they call this one. I use already M and N here. So K sub 1, K sub 2, until K sub, let's say K sub J. Okay, number of elements. So you have here, so M plus 1, N rather, factorial over M factorial N factorial. So this formula using permutation multi-set, is actually equal to, using the combination M plus N factorial over M factorial, and then you will have, of course, diba? Using your n taken r is actually n factorial over r factorial n minus r factorial, so m, then your n is m plus n minus m factorial, which gives us m plus n factorial over m factorial and n factorial. Okay, this is still even equivalent to m plus n taken n, because you will be changing this to n, that's m here, so you'll have the same result. In short, the permutation multiset of all the movements, or horizontal and vertical, identified by ones and zeros earlier, which is this, is just equivalent to this combination here. In short, going back to our shortest route in a rectangular grid, you can solve for the number of shortest routes if we're going to use here the formula m plus n combination m or n, it depends on which you will use, taking that m is actually the number of your horizontal movements, not the streets, okay? And then your n is number of vertical movements, not the streets. If you're given with your vertical street and horizontal streets, simply subtract 1 for both of them, you will get m and n, and you will have here this formula to identify the shortest route. So in the next videos, we will have examples or identification of shortest route using this formula. Hopefully this formula is clearly identified here for some of the illustrations and the derivation portion here. Again, I wasn't able to show you the derivation from this to that, but basically they tell the same thing if we're going to break them step one by one independently. Okay, thank you very much for watching.